Here is what we're going to work on now. So we've been talking about electromagnetic radiation. I'm going to go ahead and tell you what I start on today is going to be something that's going to be a little weird to you, because either way it goes, there's going to be questions. Because this lesson and the next lesson, they connect together. But I've found out, I've tried it going with the other lesson first, and it's more confusing for kids and we spend more time on it. I do this one first, kids get it, and then whenever I go to the other lesson, they're like, oh, that's what that is. So y'all probably gonna be like little Hannah right now and start looking and saying, what's that? It's super cute.
Can I go for my water bottle?
Oh my God.
I'm thirsty.
You got 30 seconds. So what we're gonna work on are called electron configurations.
I remember sort of seeing children's read something that fast. Well, I mean, I have, but like.
Now, when you look at electron configurations, what electron configurations are all about is where the electrons both are. So where the electrons are at. And we have certain ways of symbolizing this, and they go by 3 different names. So this is a little foreshadowing. The first one is what we call orbital notation.
30 seconds needs.
The second one is called electron configuration. And the third one is what we call noble gas configuration.
Teachers, we had one bus that just got here. Those students are signing in, but they'll be on their way to class.
So what happens here is that they have these 3 different configurations or notations are the ways that we're going to symbolize where the electron's at. That's all it is. Every one of them deals with the same thing, but they all look different. This is the thing that's going to make your life lovely. You're going to love this. This is the thing you're going to beg me for a quiz on, because you're going to get the pattern, you're going to love the pattern. So, let's hop right to it. Whenever you're going to look at doing electron configurations, there are certain rules you have to follow. So, let's talk about the rules to follow. What?
About the rules like that.
Joel, are you aware that you spelled the rules wrong?
You what?
It's actually supposed to be R-U-L-E-S, not Z. I don't know if you knew that or not, but.
That looks like
Yeah, it's rules, guys.
Oh
my
Disney Channel.
Rules suck.
I break the rules.
He's so gangster.
Bro, how long? They haven't done that in years, have they? The Disney Channel thing?
Okay, so
Watch Disney Channel.
first rule we got to follow. I'm going to find these as we go through them. You have to know these rules. This is the hard part. I'm foreshadowing this. I'm telling you this straight to your face. Look into the camera and hear me. You'll see me on your screen.
Yeah.
You must know the rules. This is where people always get tripped up. The first rule
What is the first one, Mr. Hall?
has a weird name.
What is it, Mr. Hall?
Off-ball principle. Off-ball principle.
Softball principle.
Off-ball.
I'm gonna remember that part. Softball principle.
Tonight is in my ear.
Off-ball principle states the electron will occupy the lowest energy level available. Lowest energy level possible.
Electron will be force.
What the off-ball principle gives us is something very special. What this is called fill order.
Filbert?
In order to get the fill order, you have two options. Option one is mine, my personal favorite, the periodic table. What is Mr. Hall going to give you on your quizzes? The periodic table. So guess what you get? The periodic table. So if you learn how to read and break down the periodic table, you got it in front of you. Or you have the option that I hate.
Uh-oh.
Option two
I'm gonna go with that option.
is doing this. 1S, 2S, 3S.
Oh,
That's a lot of S's.
So you make a column that goes 1 through 7S. Next to that, we're going to make the P column, but it starts at 2P, 3P,
What shenanigans are you doing?
P,
What is this?
7P. You have that option. Now, the next column,
I swear if it's like 3Z, 4Z, 5Z.
do the D's. So 3D, 4D, 5D, 6D.
Wait, does it go to 70?
Nope, I'm 7D. The 7D exists, yes, but we do not have enough electrons in order to worry about 7D. Then, I think this will show up better. We have the F's.
Oh no.
4F, 5F.
No, it could be crazy, but it looks like it's getting smaller.
Now, here's what you have to do is run diagonal lines through it, but you have to run it properly. This is the part why I don't like this. Kids can mess up on their lines.
Scary, just a hawk.
So all I'm doing is running the lines.
Just have
That line is now crooked. That is a wavy line. Very bad.
what's going on.
If you choose this option, you have to be able to do the lines properly. This is why I do not like it, but I still give it to kids. So the order that we go through it is all laid by the lines. You start at the line and you go all the way through. Then you go to the next line, go all the way through. Next line, all the way through. So the fill order that we end up with goes like this.
Oh boy.
Oh, there is a third option.
Oh,
Option 3 is you memorize it.
wait, so
I'm gonna suck at option 3.
is option 2 called fill order?
No, that's option.
No, this is the fill order.
Oh, that's filtered. Oh.
Fill order is how the electrons are going to fill into the orbitals. I know you don't know what an orbital is yet.
Oh no, I know. what
I
that
see
is.
you looking at me like, where was that? 2P, or not 2P, that is the question. 3S, 3P, 4S, 3D, 4P. The weird thing is I've done this so long, I kind of have the memory. 5S, 5P, wait, no.
Kinda want some fruit.
4D, 5P,
Pineapple.
6S, 4F, 5D, 6P, 7S, 5F, 6D, 7P.
I made an oopsie.
What is it? It's option 3. I was trying to look at that and I was messing up, so I just had to do it from memory. This is an option. It's not the option I like.
If I wasn't a chem student and I was looking at this, I think you were crazy.
Yeah.
1, 2, 2.
Why do you think I leave it on the board when kids come in? It's fun.
This would make me not take him. That's all.
What does all those mean?
All right, for option 2, Mr. Hall has to give you a gift.
I keep getting spoiled. I'm so bad.
Shouldn't have.
I'm blushing. I'm kicking my feet.
6, 4.
Liv, my goal is by the time we're in January, we're having full-on conversations. I think I counted right. If I miscounted, just yell at me.
Why does?
All right, I've gave you a periodic table for a reason. Everybody got a new one?
Yeah.
The reason I've gave you a new periodic table is because of what we're getting ready to do with the periodic table.
Are we doing shenanigans on it?
We're doing shenanigans.
I should brought my pins today, Mr. Hall. You should have warned me.
I told you any day you come in here, have them. Okay. Here's how I like to do the field order. The first thing you have to do is you have to know the blocks of the periodic table. The blocks are letters. S, P, D, and F. They have special locations on your periodic table. So first we start with the S block. So S block are columns 1 and 2 off the periodic table. Now I'm going to encompass all of this. This is S block. Here's the thing I need you to get though. With following this method, there are some exceptions to the rule. Here's the exception here. Helium that's over here by itself, treat it like it sits right here. Helium belongs to the S block. The reason helium is by itself, I'll go on and tell you. Helium sits by itself because it is a noble gas. That's what the 18th column is. So that's S block. Now we go to P block. P block is columns 13 through 18. Now here, at columns 13 through 18, do not include helium. Where does helium go?
That's not.
Thank you. So this is P block. Here's going to be the really funny thing is, you know how we joke around and say that kids come in after missing a day of chemistry and they feel like I'm speaking French? Kenzie and Emily are going to come in here tomorrow, the next day, and they're going to be like, what is these S's, P's, 1s, 2s, 3s?
She's never gonna miss another day. The first day she misses, we do this.
Kenzie picked a really bad day.
Next is D block.
D block, straight up.
D block has a special name, it's the transition metals. It's 3 through 12.
That's pretty big.
That's a big difference. Sure.
Bless you. Wasn't sure if that was a sneeze or a cough.
It was a sneeze.
My wife sneezes really funny. If you've never heard her sneeze, it is hilarious. Because she'll start off and it's like really quiet, and then it's like she's trying to push it through. I'm like, wow.
Favorite block.
I like S block.
I'm a P block type of guy.
Down here at the bottom is the one that everybody forgets.
I'm a D block dog.
Lanthanides and actinides are at the very bottom. They have a very special name. This is F block. Do not forget about F block. Now, whenever you look at this, there are certain rules that go along with it. I'm going to write something on the board, then I'm going to come back here. So what we're dealing with is on the periodic table. So this is option 1.
With those two little numbers right there, bro. 39.
Option 2,
57. I just said.
on option number 2 is the periodic table. If we're going to use the periodic table, you have to remember these rules. The number is n which follows this rule. Following rules. For S, so this is for S block. Well, I might as well just write that down because you are going to be like, for S block, N equals row. So whatever row on a periodic table you find yourself on, that's what N is. For P block, N equals row. Those are simple. D and F is where it changes.
Mr. All,
Yeah.
what is a row and what is a column?
I'm going to show you in a second. Rows are left to right, columns are up and down. D block, N equals row minus 1. So whatever row you find yourself in, you will take it and you will subtract 1 from it. F block, N is equal to the row minus 2. That's how we get the number. The letter is simple. Where do you think I decide if I need to put an S, P, D, or F? S, P, D, or F. What about the periodic table?
Where you're at in it, which block you're in?
Which block you're in. If I run through the S block, guess what it is? Dash.
So,
Ask a question. Okay.
we'll just pick it up.
Nerd. He's gonna ask, what is this all used for? Are we gonna learn this tomorrow?
That is not what I was going to
Well,
ask.
Well, tomorrow you got lab.
that's what I was gonna ask.
Yeah, it's time for us to go.
It is.
Except I don't wanna.
I understand. I wouldn't want to leave either.
Are you really going to get in trouble for an extra 10 minutes?
Yes. Absolutely.
Just tell him you tripped and fell.
Honestly,
That's
he's
what I
never said anything about me joining the Zoom class like 30 minutes late when I forget sometimes. So I doubt it. But
Yeah, but if Miss Collins knows that you're not in there, we're all in trouble.
Miss Collins.
And I don't feel like getting called to the office.
Miss Collins would be mad, which is weird. Why would Miss Collins be more mad than the teacher?
Here's how this goes. Where do numbers start?
0,
2.
100.
Okay, so go from 0 to 100. You're gonna count 0, 2, 3, 4. Same thing here. The numbers tell you where to go. The atomic numbers of the elements are literally going to tell us where we need to go and what we need to end up doing. So, let's check it out. Rows are left to right. Columns are up and down.
Yeah.
Okay? So I come here. What row is this? 1, there's 2, 3, 4, 5, 6, and 7. So there's the rows of the periodic table. Now, let's start it out. We follow the atomic numbers. So I start here at 1. I go through. What row am I?
1.
The first row. What block?
S.
So 1S.
Oh.
Is there anything else up here to run through?
Yeah.
Really?
Mm-hmm.
Why?
Because it's part of this block.
What? But I already ran through it.
Stop the cap.
Stop lying to me.
Remember, helium's over there. This is already ran through.
How do we just, like I know it is, but
Don't talk to me.
never mind.
All right, so we went all the way through the first row. Let's go to the second row. What's this?
2S.
So 2S comes after 1S. Anything in the D block here?
No.
No? What about P?
Yeah.
What's this?
2P.
How'd you get that?
Because second row, P block.
Second row P block. Remember, for P block, N equals row. So 2P. You went through the second row. Let's go through the third. What's this?
That's
3S.
3S?
Yeah.
Okay. So what about here?
No. Well, P block.
So wait, we don't go 3D?
No. Not there
But
yet.
3D exists.
Yeah, but we're not there yet, Mr. Hall.
Well, where are we going next?
We're gonna go to P block.
So
3P.
3P.
Yeah.
This is why I like the periodic table.
It's alright.
I don't know how many times kids will go 3D. 3D ain't there yet. Because watch what happens.
4D.
4S.
4S.
And then what about here? Well, now I'm hitting the D block. So what's that?
4D.
4D?
Minus 1.
Look on the board. D block, N equals row minus 1. What row you in?
4, so 3.
Fourth row minus 1, that's 3. So that's 3D.
That's so cool.
I love 3D.
Now, where we at?
2D? 2P. Wait, no?
Nah, you got this.
I'm losing my mind.
4P.
4P.
4P, how do you get 4P? N is equal to row. Now we go 5.
5S.
This is the part where you start picking it up. Look, I'm in D block. Remember,
4D.
4D,
Then 5P.
then 5P, then
6S.
6S. And you're going to see why I use this periodic table. Follow the atomic numbers. I go from 56. I should go to what after 56?
57.
57. That's 71.
Close enough.
There's literally a box here. The box is there because the lanthanides actually fit right there.
Oh, that's what I'm saying.
But instead of having this big, huge, long, drawn-out thing, we drop the lanthanides and actinides down.
We should make the periodic table like an animal.
That is so cool.
So now you're in the F block. What's this?
That's
That's F of 6, 6F.
6.
6
Minus 2.
minus 2,
That's 4F.
so 4F. Now look, 70, go to 71.
This is
So
so
back in the
cool.
D block. What row am I?
6.
So what is this?
6P. Oh, 16. 5D.
5D. Remember, rho minus 1 for D.
I'm not paying attention. I just really
Then
like.
6P.
I just really like the P's.
7S. Look here, another placeholder. I go from 88, I should go to 89. 89's down here.
5F.
Actinium.
I mean, if I live
5F. Then I come back up here, which is
16,
6D, and then
7P.
7P.
Okay.
We just did the same field order that's on the board.
You want to get the periodic table?
You will get a periodic table on your quiz.
Okay.
That does not change. Questions on that?
You don't gotta mark it up.
Okay, that's the off-ball principle. And option 3, if you choose, is just a memory. I don't recommend doing the memory, but that's up to you. So you have that option. Then we go to what is people's probably favorite rule. I better do it in purple. This one is called the Pauli exclusion principle.
Is this part of the option 2, or is this a whole different thing?
This is a new rule.
Gotcha.
This is rule, oh, I should do it like this, 2, sorry. Pauli exclusion principle is not that bad. Pauli exclusion principle states that, and this is very important, no 2 electrons for the same atom can have the same 4 quantum numbers. We haven't went through the quantum numbers yet. Quantum numbers are in the next lesson. But what you need to understand is what the quantum numbers work like. Quantum numbers work like zip codes. Can Pineville be in area code 24870? No. Why? Because that's Oceania. Exactly. You cannot occupy it. Can Pineville be 24822?
No.
No. That's Clear Fork.
You're just flexing on us.
Third rule. Huntsville.
What is Pineville zip code?
Also, I don't know. Here's what Huntsville states. Orbitals of equal energy levels will each obtain 1 electron before obtaining a second.
I don't know what orbitals mean.
Overall can,
I will let you know orbitals are the probability areas of where we find electrons. So this is where electrons are located at. That's what orbitals are. Here are the 3 rules. I know I spent a lot of time on off-ball principle because you needed to get the field order. Here's the thing before you go out of here today. You need to know all 3 rules, what they are, what they state, what they define. Kids do great when we get into doing the electron configurations, but then they forget the rules behind the electron configurations. In my class, you must not only know what to do, but you have to know why you're doing it, and be able to explain it. Do you understand?
Yeah, what's the overall again?
It's probability area of where the electron is. We will cover that more in depth. Have a great, wonderful rest of your day.